Hi, this is Ashik Hussain. I am a PhD student at Macquarie University working under the supervision of Dr. Ralph Schwitter. Now I am going to present my paper titled Specifying Conceptual Models Using Restricted Natural Language, which has been accepted as a long paper in ALTA 2018. This is the overview of my presentation. At first, I am going to give a short introduction to conceptual modeling, and then I want to discuss some related works and the motivation behind this work. After that, I'm going to discuss the proposed approach and the proposed architecture to conceptual modeling, followed by reasoning on conceptual model specification, conceptual model generation, future work, and conclusion. Introduction. The key activity to design an information system is conceptual modeling, which brings out and describes the general knowledge that is required to build the system. Traditionally, this activity involves domain experts and knowledge engineers to work together and build a conceptual model of the system. Popular conceptual modeling techniques. There are a number of conceptual modeling techniques available for designing an information system. They are entity relationship modeling, object role modeling, and object-oriented modeling. Entity relationship modeling represents an information system in terms of entities, attributes, and relationships among the entities, whereas object role modeling uses a fact-oriented approach for modeling an information system. Object role modeling represents an information system in terms of simple facts. Object-oriented modeling, such as Unified Modeling Language, is a graphical modeling framework for object-oriented software system design. UML is basically a vast graphical modeling framework which supports different types of diagram. For this work, we have considered UML class diagram because UML class diagram is aligned with object role modeling diagram and entity relationship diagram. All of them consider data perspective while designing an information system. This slide describes the motivation behind our work. So in conventional approach, domain expert and knowledge engineer sits together to decide or to identify the specification of the system, and based on that specification, knowledge engineer tries to build the conceptual model using a popular conceptual modeling technique. The advantages for such traditional conceptual modeling process are easy to generate, easy to understand for humans, well disciplined and well established methodologies are available. The disadvantages are no precise semantics, people who use it wave hands about it, verification or better validation done informally by humans, machine incomprehensible, automated reasoning and query answering are not possible. To overcome these disadvantages, in 2013, Dave Calvanese proposed a solution. He suggested that we should use logic while designing a conceptual model along with these modeling techniques. The advantages of using logic are precise semantics for all verification, allow for query answering, machine comprehensible. The disadvantages for using logic are difficult to generate logical notations, difficult to understand for humans, too unstructured, and no well-established methodology available. Automated reasoning may be impossible. To overcome these disadvantages, we propose to use restricted natural language for conceptual model specification, and we argue that if we use restricted natural language as a conceptual model specification, it will be easier to generate logical notation. Automated reasoning will be possible. It will be computer processable and easily understandable to humans because we are using restricted natural language. Let's see, what is a restricted natural language? A restricted natural language, a subset of natural language that are obtained by restricting the grammar and vocabulary in order to reduce or eliminate ambiguity and complexity. These restricted natural languages are also known as control natural language. There are two types of restricted natural language: those that improve readability for human readers, for example non-native speakers like me, and those that enable reliable automatic semantic analysis of the language. This slide gives some example sentences that has been constructed using restricted natural language, and they have their formal translation on the right hand side of the table. So natural language, if carefully controlled, provides a more readable and writable formal representation without a loss in generality and expressive power. This has been a quote by Carol Carnegie, who designed a restricted natural language named Attempt to Control English. Related work: there has been a number of works on formalizing conceptual models for verification purpose. Description Logic for Conceptual Modeling by Calvanese in 2013. ORM2 Formalizing and Encoding in ALTA by Franconi in 2012. Reasoning on UML Class Diagram by Berardi et al. In 2005. Reasoning about entity relationship diagrams with complex attribute dependencies by Lutz in 2002. These approaches first represent the domain of interest as a conceptual model and then formalize the conceptual model using a formal language. So all these previous approaches have mentioned that the description logic DL-ALCQY is well suited to do reasoning with entity relationship diagram, UML class diagram, and ORM diagrams. The constructs for this description logic family are atomic concept, atomic role, atomic negation, conjunction, unqualified existential restriction, universal value restriction, full negation, qualified cardinality restriction, inverse role. There exists work on ontology editing and authoring using restricted natural language and also specifying and verbalizing logic programs in control natural language. Owl Simplified English by Richard Power in 2012, Rabbit by Donald Denux in 2009, SView by Carol Cali-Durand in 2008, Round Trip Ontology Authoring by Brian Davis in 2008, Clone Control Language for Ontology Editing by Adam Funk in 2007, Light Natural Language by Raffaella Bernardi in 2007, Specifying and Verbalizing Logic Programs, that means like answer set programs in Control Natural Language by Rolf in 2018. Unlike previous approaches, we propose the following. Write the specification of a conceptual model in RNL first, then translate the specification into DL-ALCQI. Existing description logic reasoner such as Racer or Hermit can be used to check the consistency of the formal notation. After that, generate desired conceptual models from the DL notation. This is the system architecture for conceptual modeling that we have proposed in our paper. So here, a domain expert can write the specification in RNL and then he or she can generate the diagram from this specification. The system basically translate this specification into description logic, and from this description logic representation it generates the diagram. And this system architecture basically works in a round-tripping fashion. That means like if you write the specification, you'll be able to generate the diagram. If you draw the diagram, you'll be able to generate the specification. So in this paper, we just represent the one way, and currently we are working on the reverse way. Let's see an example scenario. A learning management system keeps track of the units students do during their undergraduate or graduate studies at a particular university. The university offers a number of programs and each program consists of a number of units. Each program has a program name and a program ID. Each unit has a unit code and a unit name. A student can take a number of units, whereas a unit has a number of students. A student must study at least one unit and at most 4 units. Every student can enroll into exactly one program. The system stores a student ID and a student name for each student. So for this example scenario, what we do, we just reconstruct this scenario in RNL, and the reconstructed scenario looks like this. The first two sentences basically says that student is a disjoint class with unit and program. Sentence C says that every student is enrolled in exactly one program. Then sentence D says like every student studies at least one unit and at most 4 units. So basically it describes the object property between student and unit class. And then Sentence E says that every student has a student ID and has a student name. So this sentence basically describes the data property for the class student. So in this way, we also describe the properties for program and unit. A feature-based phrase structure grammar has been built using the NLTK toolkit to parse the above-mentioned specification. Below we show a scaffolding of the grammar rules with feature structures that we used for this case study. So this grammar basically parses the RNL specification and generates syntax tree for each sentence. The resulting syntax trees are translated into OWL XML notation. For example, consider sentence C in the RNL specification. So if we see sentence C, it says like every student is enrolled in exactly one program. So the grammar parse this sentence and generate this syntax tree, and from this syntax tree our program convert it to an OWL XML notation. This OWL XML notation basically describes that enrolled in is object property which has a domain class student and range class program with exact cardinality of 1. Reasoning: after generating the OWL XML notation for the RNL specification, we use OWL-ready that includes the description logic reasoner Hermit for consistency checking. For example, consider the inconsistent sentences below. Sentence A says that no student is a unit, and sentence B says that every unit is a student. So the first sentence says that student and unit are equivalent, like disjoint class, and the second sentence says that student and unit are disjoint class. So clearly these two sentences are inconsistent. So the OWL XML notation below shows how this inconsistency is reported after running the reasoner. The reasoner reported by mentioning OWL nothing property. So once we have generated the OWL XML notation, then we map this notation into entity relationship diagram, and we use this algorithm to do that. So this algorithm, what it does, it takes the OWL XML notation, and in the notation every class becomes entity in the ER diagram, every data property becomes the attribute for that particular entity in the ER diagram, and every object property becomes relations between the entities in the ER diagram. So this algorithm basically take the logical notation in description logic and generate an SQLite script. We use that SQLite script in the schema crawler library to generate the ER diagram. Future work: to develop a fully fledged RNL for conceptual modeling which can cover all these three. That means like entity relationship diagram, object role modeling diagram, and UML class diagram. Develop a conceptual modeling framework that will allow users to write a specification in RNL and will generate a conceptual model from the specification. So the main key idea is to facilitate the verbalization of the conceptual models and to allow users to manipulate the models in a round-tripping fashion. That means like from a specification to conceptual models, from conceptual models to a specification. Conclusion: in this paper, we proposed a novel approach to conceptual modeling where the domain experts will be able to specify and construct a model using a restricted form of natural language. This approach has several advantages. It uses a common formal representation to generate different conceptual models. It will make the conceptual modeling process easy to understand by providing a framework to write a specification, generate visualizations and verbalizations. It is machine processable like other logical approaches and support verification. So in this work, we try to overcome the disadvantages of using logic in parallel with popular conceptual modeling techniques. Thank you. If you have any questions, I will be available via Skype. Please feel free to ask.